Good morning, this is Dr. Christopher Windmill from the University of Derby presenting the keynote speech at the Software Engineering and Machine Learning Conference for 2023 on applying lessons learned from software engineering education to making digitally augmented business workflows more usable. So for those of you that are interested, this is my background. So my engineering doctorate is from the University of Glasgow in system level integration, and my undergraduate degree is from the University of Edinburgh in electronics and computer science. My research areas are really around virtual and augmented reality, computing in healthcare and mental health, and things like serious games and sort of computer games in general. Really the focus of this is how can we assist humanity, civilization, using computers as our source? How can we make games work for people? How can we make systems that support people? So I've done a lot of lecturing, things like software engineering, team projects, games development, networking and distributed systems. So I've got a very broad range of sort of lecturing experience, lots of students have been seen, and in terms of research, very widely varied. Currently looking at sort of knowledge transfer partnerships and things like digital twin asset management and the gamification of business processes. So if anyone's got any questions, please do get in touch at c.windmill@derby.ac.uk. I want to start this presentation off on a very positive note. It's something I think that we've done very well in the software engineering community, and something that we do very well in the software engineering pipeline, from student through to software developer, engineer, manager, analyst. And something that in my experience has been done very badly in many businesses. The digitization of workflows, and more importantly, and more specifically, the engagement of stakeholders at all levels of our organization with these processes. So, if we start with academic degrees, we generally look to teach students about the fundamentals of programming, of teamwork, project management, and task analysis, regardless of their core path through education. So, if we perhaps assign some sort of academic rigor to degrees, on the low end we might have something like, game design, where here we're primarily looking at things like user interfaces, user experience, and similar, rather than the mathematical analysis of code. At the other side, we're probably looking at something a lot more mathematical, so computer science. How do we verify that code does exactly what we expect it to? How can we produce safety critical code? So no matter where we put things on an academic rigor, we expect all computer science students, all software engineering students, all game students to have encountered these real life issues, the concepts of things like project management, how to work in a team, and we expect them to have come through this using a series of tools to support their learning. So no matter where in the pipeline a student starts, we all walk a fairly standard career path, from junior developer, adjusting to the workplace, being mentored, through that real world development process, to senior developer, mentoring others, or perhaps sub-specializations, then into roles like project or engineering management, software architects and analysts. And at each stage of this pipeline, we reinforce those core skills that students learned, and we work with the same tools continually going forward. But where do these skills come from in other degrees? How do we ensure that our students can engage with people from different backgrounds to understand what they want, and more importantly, to understand what the people we're working with didn't express that they actually wanted? So then, how do we make software that people from these different disciplines will engage with and do so in a safe, secure, appropriate, documented, auditable manner? So I've had a recent number of people going, well, won't ChatGPT just really replace software engineers? But it's great when we can get it to answer a question. But if it doesn't know the question we're asking, if it doesn't know something hasn't been asked, how can the intelligence know to ask an additional question, especially when the client often doesn't know what they want to express? I'm going to put this forward then as sort of a simplification of the problem statement. What we're essentially looking at is things like version control, access control, accessibility control, and flow control. So I'm going to take an example from my own workplace here. We've had paper forms to manage quality control and improvements on our modules, and these worked generally quite well. Everyone filled in the paperwork, paper went to the administration service, and then we hit a bottleneck. Digitized versions of these were often out of date. We had flow and version control issues. So which piece of paper was actually the most up-to-date version? Had that version been scanned in and was now available under our canonical documents, or was it still waiting somewhere in the system? So we decided that wasn't great, and we upgraded to a spreadsheet. And being wonderful technical programmers and everything, most of us really liked the spreadsheet solution. It worked, we could interact with the tools, and we could write programs that interacted with the spreadsheet. We had a single point of truth, we could control access to the document, but spreadsheets aren't very well known for their version control software. So we had issues around version control, which one was the correct version, what happened if someone didn't tag when they'd updated something, and also some accessibility issues, because it was pretty much everyone has access to the same level, or no one has access. Then, recently, we updated to a digital form, so wonderful web page. It had drop-downs that make things easier, and suddenly, rather than being able to copy and paste between cells on a spreadsheet, we had to fill in the form multiple times, once for each module, once for each course. You couldn't easily add notes. You couldn't add anything like accessibility workflows that worked in the Microsoft suites. So this actually affected some of my colleagues in that tools they needed to do their job now didn't work. So a lot of the time what we'd actually done now was replicated the issues we had on paper. Did I submit this? I don't know. I don't know how to check. I'll submit another one of it. We added accessibility problems. We had accessibility controls. Who actually had access to this? We didn't know. And this isn't the first time I've seen an organization take a paper-based task and effectively replicate all of the issues that occurred on a paper-based version. And this isn't a very complex process. It's really quite simple. So when we're considering something more complicated in a business, such as compliance documentation, suddenly we have many different people from different roles, different backgrounds, working on that task. So how can we take that understanding that we have on building software that works, software that allows us that traceability, and build that into software that supports users? Fundamentally, all development, whether at a university level or as a professional, involves a creative process, and that follows through what organizations such as the Project Management Institute have formalized and written down. So if we look at their 5-stage model, almost all software developers or engineers will have had experiences of stages 1 through 3 when they're a student, possibly something in stages 4 and 5. The review and analysis of the project itself are often non-core objectives when we consider students, but we need to consider the whole life cycle as we go through. And this is where we see a lot of institutional knowledge and the transference of that knowledge, and that institutional knowledge becomes part of software development culture. We talk about things, we share concepts, we share ideas, we share what went right and what went wrong. So most software development companies have someone that's responsible for stages 4 and 5, and for ensuring that that feedback loop is completed, for ensuring that the information is fed back into the development process and goes all the way down to the newest, most junior programmer, and they learn from that as well. And that can be formalized through things like code reviews, or simply through things like mentorship. So fundamentally, a lot of the work we do is very self-similar. Whether or not we're designing the next Amazon or designing the internals for a simple function, we go through these processes. And at each stage of their careers, software engineers get mentored by each other, either explicitly or implicitly. And they're exposed to these processes. They see what is happening to their seniors, and they learn through all this institutional knowledge that we transfer. So how do we replicate that? How do we ensure that institutional knowledge reaches the right people at the right time with the right level of access in a traditional business workflow? We can take a lot of lessons from our own tools when we're looking at this process, and a lot of the tools we use are actually pretty good at this stuff. They're good at making knowledge open, accessible, and manageable. So if we take a simple tool like a Gantt chart, it immediately expresses how long a project is going to take, it expresses what it's broken down into, and it expresses relationships between those. If we get into more complex things, it can show errors, it can show work done, it can show who's assigned to things. So we can start to gain traceability of what went right and what went wrong. And if we move away from the very simple tools, we've got all manners of models, waterfalls, agiles, and these use tools, something simple like Trello, Kanban boards, or similar. But each of these teaches developers to approach a problem in a systematic manner, to break down projects into packages, tasks, and to track their own performance. Because if you can't track your own performance, we don't know how to improve. And if we do this well, we involve some form of individual responsibility for engaging with these tools and feeding back into the development process across all levels of software development. So let's take the step that this talk actually promised from the title. When we look at a traditional business process, we see very similar structures to those that our developers are exposed to throughout their careers. The difference comes in when we consider the actual use of these mechanisms. So if we take something like a maturity model or a process management tool, these are normally management level tools and are often quite opaque to the end user. So we'll take a basic process management tool. So process maturity management system, 5 levels, minimal process, focused processes, process aware, cross-functional process management, and goal-driven processes. Above that, optimized processes. We very quickly move from a view where the average worker has direct sight of how this works and why it works, and move into business management and a very sort of top-down approach to the problem. And we see similar levels of complexity come through things in the RM3 risk management model used in, for example, the UK railways. The lower levels of risk management are really dependent on the average worker, their knowledge, and then very quickly move up to levels of complexity that often obscure that lower level data. You can see the life cycle, traceability, but you lose sight of the bottom. And when you lose sight of that bottom level stuff, it's very easy to say, yes, my company's complying with regulation, we've got processes in place, we've got training, people have signed up to it, but do we actually know if people are following that, or are they doing the training and then failing to follow through? So lots of these frameworks are designed to be top down. A manager completes the information, and thus we lose the potential for the additional knowledge transfer within the organization, as on the ground practices and processes are lost. When we move through these models, it becomes very difficult to trace who is responsible for information and what information is supposed to represent at any given stage. If we contrast this with most good software engineering, we want to see traceability from the business analysis through the software design, development, and testing, so that we can clearly show that a requirement has been met and consideration has been given at all levels to, is this safety critical? Is it going to meet the needs? Is it going to be sufficiently optimized? Of course, when we consider it that way, we're often looking at a very base level set of goals, but a lot of these can be aggregated, and that's what we want to look at. So when we are trying to digitize these workflows to make them accessible and ensure the data remains current and traceable, what are the major issues that come up, and how do we know that the underlying data that we're working with hasn't decayed to the point where our foundations have become worthless? How do we visualize all of this? So I've been working in consulting and research in this area. I want to talk about some of the approaches to the digital augmentation of these workflows. And by that I mean the concepts that range from something as simple as literally digitizing information to allowing multi-user access to the system, generating visualizations for users to work from, and understanding what's missing in their workflows. Importantly, we're not going to take the traditional gamification route, which is generally applied to education. We're going to look at this from a business perspective. So I've pulled out the key topics I think are ones we have to consider, and those are the ones I want to focus on. So we'll have a look at how these might assist in the workflow and management of processes, the visualization of data underlying these concepts, and importantly, we're not going to try and do anything super fancy. We're just trying to make the process and the application more visible. Starting with data management, we hit the obvious ones first. Data is valuable. Not everyone should have access to data, and sometimes having access to that data is not legal. Really, this point covers some of the other points I want to make as well. We need to consider the visibility of all these components, as well as the underlying data itself as part of our software development process. We particularly need to have visibility and traceability when we're dealing with digitizing existing workflows, as we're probably going to have to prove to an outside auditor that we're in compliance with regulations and laws, and we need to be able to show how we've achieved that compliance. So data has some form of life cycle. That data degrades over time. Some data has additional legal, moral, and ethical issues attached to it. Some data can only exist in certain places, and these requirements can change with very little notice. So, what is the data lifecycle? Honestly, I don't know, and I can't tell you because this is going to vary with every application we build. But some things that are true for almost every piece of data we deal with. Data is going to be created, and that data is going to have metadata such as things like the source, where it came from, the author, and data is going to be moved, edited, or deleted. So that's the basic operations. So let's apply this to something like the RM3 model. Data has to be traceable. We need to know where the data we're relying on came from. So without that traceability, the data itself is worthless. Data must be valid. We need to know the data is up to date, we need to know it's relevant, and we need to know it doesn't have errors in it. And each of these sections must be testable. We need to be able to prove that the data underlying this is reliable and that it meets the requirements that have been set out. So, who has this data? And this is where this gets interesting, because from my experience, a lot of this data is actually, or information, is actually spread across a variety of levels of seniority, across different locations, in different formats, and with different data policies at each location. Thus, when we're looking at the data lifecycle, we need to consider all of these points and make them visible to the responsible party. We need to be able to interrogate our system to determine where data is, who owns that data, and the provenance of the data that it comes from. Data decays in various ways. It could be out of date, no longer relevant, references old material, or simply contains old references. So if we consider any code base that you guys have worked with, were there comments in it? And were those comments up to date, relevant, and appropriate? Thankfully, I can say that a lot of the code bases I've worked with, the comments were great, they were relevant, they were in the same code style, everything was fine. However, I have worked with some code bases where the comments might as well have been a fantasy novel in terms of how they related to the code. So when we take a traditional business flow, data decay becomes very important as we're dealing with a lot of cyclical processes, and we need to ensure the data remains relevant and in date. And when one of those isn't true, we need to flag that assumption based on the data is no longer assured. So any assumptions we've made that rely on that data, they may still be valid, but we need to verify that the underlying data is correct. So taking something like the business process maturity management model, how can we validate that we're still at level 5, that people understand the processes and follow them? Now, the easy solution is we have some kind of centralized training system and have records that all employees have completed it, but does that evidence that we have actually got people following this on the ground? Is that training up to date? Is that training appropriate and human-centric? Does it take into account human psychology? Thus, we need the ability to test our data, and when we're creating these kind of stacked and layered systems, we need to ensure that each layer supports the lower layers and can test that those layers are still valid and that those layers are correct and maintained. And thus, we can't assure that the assumptions at the top level are valid unless we validate the bottom levels first. Security management is one of those interesting topics that I could easily spend several hours talking about, so I'm going to try and avoid doing that and cover this way too briefly. A simple way to give access is something like user, super user, administrator. So a couple of levels and nothing terribly nuanced. We might need more nuance though, control groups or an Active Directory, and when we're dealing with large data sets and processes, there's often a lot of user groups and a lot of overlap in terms of which groups can access what based on which part of the business they're working in, which site they're on, and similar. So we don't only end up with perhaps worker, supervisor, administrator, line manager, general manager, HR manager, external auditor. So we end up with a system where we have to very carefully consider who has access to the data within the system, and thus that the data is tagged correctly so we know who should be able to access it. We need to know who can edit the data and how the versions are managed. And then this gets more complex when we've got multi-site solutions. So things like network systems, cloud distribution, gets back to those statement of the problem that I discussed before. So the technical issues around things such as firewalls, local data storage, cloud data storage. Then we get to the really fun things like sensitive data. Is that data allowed to leave a certain site, whether that's a company rule or an actual legal requirement? If not, how do we manage the geographic locality of that data? And what about external auditing? Thus, we begin to see that security management can be a very visual process. We generally like to geofence a lot of our data and control the devices it's maintained on. Sadly, when users have physical access to a device, a lot of security issues become more problematic. So, I'm going to take another real-world example for this. At the University of Derby, we have controlled USB access on all of our work machines. Staff who need to write to external devices need to ask for explicit permission from our IT services department, and if we've got a valid reason, we're granted permission to write to devices. Unfortunately, the Git command line, the Windows subsystem for Linux, and a variety of other tools that are very, very standard on the machines we work with will happily write to USB devices regardless of privileges set up on our accounts and similar. So our data is kept secure by policy, except when it isn't. If this was a normal lecture I was giving, or if I was here in person, I'd probably open up this one to the floor to ask for questions and thoughts, but I'll try and keep it simple. When we consider widely deploying our software across desktops, mobile devices, and in a distributed manner, we generally give ourselves a very large attack surface on our system. Fundamentally, there isn't a problem if we adhere to good security standards, follow guidelines and procedures, and please take that with an appropriately sized pinch of salt. Being more realistic, we need to consider where our data is geographically, and particularly what happens when a mobile device with data on it is lost or goes offline for a significant period of time. Is the firmware still safe? Is the runtime environment still safe? What did the latest updates to those devices break? So this is where we can start to really visualize information. Confirming through a dashboard or similar lets us see when a device left our geofence, how long it's been out, and gives us easy oversight over a large scalable system. That networked and cloud deployment gets a bit worse when we consider large-scale organizations, where we're often looking at cross-platform developments and all of the inherent issues that come with that. When we're rolling this out across traditional businesses, we need to consider the reluctance of users to engage with technology. We're not dealing with a group of software engineers who are all happy to learn new processes. Many of the issues I've encountered when moving to digital solutions are often reversed in others. Not everyone is happy with spreadsheets, web pages, mobiles, or even email. So when we're digitizing these processes, we need to consider the workflow itself, the different devices and their interfaces, but also how do we deploy training and ensure compliance within the users. Now, this isn't necessarily a technology issue, but it is something we need to consider when deploying these digitally augmented workflows. How do we train users, ensure retention of knowledge, and ensure that that knowledge feeds into our systems? Then finally, the update cycle. So, assuming traditional updates are driven by features, customer needs, or similar requirements, when we look at actual traditional business workflows, and particularly things like risk management workflows or process management, we have to be very aware of compliance with legislation. So, what role is our software filling? Is it simply guidance? Is it safety critical? Is it something that's being relied on to show that, for example, a train is safe to run? What time period we have when legislation changes? How quickly do we have to be able to deploy updates? A lot of this is not often deploy once and abandon the software. When we build this kind of software, we're looking to commit to supporting software on an ongoing basis, possibly providing training, or allowing someone else to do so. So, back to the point of visualization. What kind of things can we do here, and how can we keep it simple and easy? So, one of my colleagues did a PhD where he put the idea of traffic lights on Facebook. Green if the data you were typing in was safe, yellow if it was potentially iffy, red if it was something you should really consider putting up there. So, he had very good results on this, and people respond well. When something is green, we're generally quite happy with it. When it goes red, we're less happy with this. So, traffic lights applied something, or highlighting can be very beneficial. If you guys have attended the workshop, We've got a wonderful example in there of highlighting decay and effectively trying to turn keeping data concurrent or up to date as effectively a whack-a-mole game. We can use things like task badges and similar. So while workers and employees may not respond to the idea of stickers, we do like to see things ticked off lists. We like to see completed lists. So having task badges that appear and disappear, show how well we're doing, can be very beneficial. And then things like charts and plots. Taking information out of a textual format and displaying it to somebody in a way that's easy to grasp. That's where a lot of our visualization can come in to make this better. And then we can do more complex things. We can have animated dashboards. We can do things like geographical maps, heat maps, and we can really show where our data is, how it's being managed, and how it's being approached. So, pardon my horrible PowerPoint diagrams here, but I'm going to take something simple like RM3, and it's really not that simple underneath, but for the purpose of today it is. So, I'm going to take this wonderful example here. We have a level 1 task, and we have some documents supporting it, and it's all good. We have a second system where we're at level 3, and we've got a document supporting it, and it's all good. And a final one where we're at level 2, and there are 3 pieces of supporting documentation, all of which are good. So, a simple color-based system shows us the number of documents supporting it, and whether those are in date. What if we simply change this? So, instead of displaying this big block of 3, let's break it down. If everything is in compliance, we show it as a full block. It's nice, it's simple, your eye glosses across this and goes, yep, everything is fine. If we instead separate it out when there's a problem, our eye goes across here, and suddenly there's 3 separate obstacles that we have to work through. So here we see, are we actually achieving the top level? I've turned this grey as the idea of, I don't know if the assumptions underlying this are currently supported, please check. Level 2 is also grey. It has a document highlighted in yellow that is going out of date soon, and therefore this needs to be looked at. The bottom level is apparently still supported, highlighted in yellow. It has 1 document that's correct and 1 document that's gone out of date. So at this stage, we know, yes, we might still be level 3 here. We still have all 3 blocks highlighted. However, we have a problem with our level 2 solution in that the data may be incorrect, and we have a problem with our level 1 solution in that this has got to be updated. And a simple visualization like this, if we play onto human psychology, how the visual system works, we can draw attention to components without making many changes. Similarly, if we're considering something like geofence data, something like a simple map. So here, owner John assigned data aging out and due in 2 weeks. John is on site, the data is yellow. We're highlighting that the data hasn't left our geofence boundary, but there is a potential issue with it that needs to be addressed. In contrast, this one has been highlighted as going outside of our geofence. Now, that may not be an issue. We might have given permission for the owner of this to go off-site. We might have taken all necessary security procedures. But by highlighting them, we can say, someone has to look at this. Someone has to verify that this data was allowed to go off-site and that appropriate clearance was made. And again, if we build a more complex system, we can build in that permitting into the base process. So, thank you very much for listening to this keynote. If you've any questions on what I've talked through today, please do contact me, c.windmill@derby.ac.uk. Otherwise, thank you very much for engaging with this presentation, and I hope to hear from you all soon.